Okay, hello everyone. Welcome to a Wolfram language design review, part of our incremental language development series. It looks like we've only got 2 items on the agenda, but I know that these items are going to have lots of complicated stuff underneath them.
So this is an item from one of our older design documents where I think we'd classified this as a design chestnut, but the idea of should we, and if so, how would we hook interpreter into pattern matching on the left-hand side of a function?
That's complicated.
Yeah.
This is even a good idea.
Right.
So I would say probably not.
Yeah. I mean, I think we'd probably all be in general agreement. We don't want calls to the pattern matcher to be taking multiple seconds because we have to parse something on alpha. So we'd have
to that's hopefully changing because we're hopefully getting local alpha parsing for most of this stuff. I don't know what the status of that project is, and I'd like to hear about that. If somebody could walk that off. Go ahead.
Well, I was just going to say, I mean, it also seems like, right, I mean, normally with interpreters in like API functions and form functions and so on, there's a single sort of type signature quotes, right? Like there's no like, did it match a city? Oh, it didn't match a city. Then if it's not a city, it must be a string. A string is more general than city or something like that, right? It seems like it makes more sense, makes less sense to define it like an actual down values than it would make sense to have an object like an API function that's sort of like a callable function with a single type signature, which you could use. But I think we might already have that.
What are you suggesting?
I'm just saying that I think with patterns, the whole point is that you can actually tell, which is more specific, which is less specific. You have an idea of that it matches or it doesn't. With interpreters, we don't usually do that. It's usually just you declare this must be a city. If it isn't, you're going to fail. There's no match or not match. It's just it has a single type that it's targeting.
But wait a second. I mean, this is going in a kind of a direction that I was thinking about, and it's if you can look at it as form function, API function work with types, not with patterns. But it's not true. I mean, interpreter does support some types.
Okay, listen. Let's cut this short for a second. Okay, we've got the following syntax. We've got things like x colon blank, right? That matches blank, matches any expression. Blank integer matches any expression with head integer. We all know this. So the question is, does it make any sense to have what you wrote, whoever wrote up at the top there, something like this? Right? That could make sense.
Well, yes and no. Because I think it does make sense to have some situation where you say, I want to match types.
No, but forget the types. Just tell me why this doesn't make sense.
Because
if X will be bound.
Yeah. What is X bound to? Is it bound to a string that contains a number, or is it bound to the number?
Instead of saying number, you should say city, right? And then the question is X going to be the string New York, or is it going to be the entity New York?
Right. So let's do that. So then the question is, when we say f of quotes New York, what does it do? That's really the question we're asking.
Right. Well, but no, the question is, what is X bound to? Because by any sort of pattern logic, X is bound to the string in New York, but that's not very useful.
I agree. So that as such doesn't make a lot of sense.
Right. So again, it seems like the more useful thing is to have something, and again, I think maybe you can already do this with like API function or something like that, where you essentially define, you get an object where it expects that in this argument, I'm going to take a city, in this argument, I'm going to take a number and so on, and then it runs a function on it.
Right. I mean, if I do this, for example, and I do this, and I say, apply this to X arrow NYC.
Right.
Why is it so unbelievably slow? That was unbelievably slow. Okay, so can somebody send this to the speed alias and look at it?
The thing is that probably
I don't want to know a theory.
That you were loading a bunch of packages.
I don't want to know a theory. I want somebody to look at it. I want somebody to fix it.
Well, what happens
Don't
if
really
you
care about
evaluate it
that.
again?
Yeah, okay, we can try that. That's as far as we're going to go. Okay, works nice and quickly. So let's find out why it was so slow, and let's fix it. Okay, but
Out of curiosity, if you, well, actually, you shouldn't do. I was gonna say if you like turned off your internet and then ran it again, would it work? Is it cached locally? But you can't do that.
I can't do that. The
Well, you can block.
Okay, let's not go there. Let's not waste time on that. Okay, there's a problem in loading packages here. We should fix it, right? So, but the main point here is that this is a mechanism by which we can do what we want. It's a little bit messy because it's got all of this stuff about APIs and so on in it. So the question really, I think, is there, I mean, this reminds me a bit of options pattern. I've never found that mechanism that wonderful, right? So, things like this, right? Where now we can say then this goes to something with option value. Am I making sense? Seems like a similar mechanism.
Yeah, but it seems to me that what you're really interested here is the interpreter type system rather than the fact that you're turning a string into an object. Like, I don't think that the main event.
What we're interested in is the fact that we're matching. You're right. We're interested in, we're matching an entity, but we can do that. We can say, X : entity, and not that people do this very much. Entity city triple blank, right?
That's kind of goofy because you could have what if it's wrapped in data or something like that. I mean, it's writing a pattern like that. It's brittle.
Okay,
you want to have a function,
but
the way to do it would be you'd have some kind of entity queue and entity queue.
Yeah, but then you have an
city,
entity
comma,
queue,
blah.
then you have a number queue, then you have a string queue.
No,
then you
wait.
have
So the things that we could do here are, you're saying if I have something like location, which can match multiple things, I want to know, do I have an expression? Okay, so the issue is, do I have an expression that could represent a location? Is that correct? Not the interpretable thing, not the string, but an expression that is the possible output from a location interpreter. Is that correct?
I think the location interpreter takes kind of whatever in terms of entity and always returns a geoposition or something.
Okay, I'm asking the following question. What we want for our pattern matcher is something which matches expressions, not strings. Correct?
Yes.
Interpreters don't need to take strings. I thought they could take other things too.
That is true, but what we're interested in here is not the transforming of string into things, it's the transforming of types into patterns.
Okay, can we stay?
Right.
Okay, let's try this. Is this going to work? Yes, that worked.
Right. So the use case is, I think, okay, if I understand the use case, it is I have a function that can take any kind of, geoposition specification, whatever it might be. How do I write that pattern?
Yes. Right. And the point being, which Carlo is, I think, correctly making, that we have essentially it's not really a fuzzy type system in the interpreter world that is things that can represent a location as the location thing, right?
Yes and no, because the interpreter type system is designed also around the fact that we are taking strings and transforming them into
Okay,
things.
I understand that. But the point that we're making here is we are interested in something that can take an expression representing a location. Is that correct?
Yes, that is correct. What I'm saying
Okay,
is
thank you.
this
That's
is
what we
not
need
the
to know.
interpreter type system. Exactly.
Okay, that's what we need to know. We want something which can match any expression that represents a location. Is that correct?
Mhm.
And ideally also, puts
No,
into
no,
some
I don't think
canonical
so.
form.
Any that has one, not represents one.
Okay, fair enough. Fair enough. So in other words, this might be, the Battle of Hastings or something. And we should be able to say f of this, and then what we want to be able to do is that on the right-hand side, so we will have defined f so that on the right-hand side, it can say geodistance. Well, I shouldn't say this, that it's going to be, okay, let's say here is geodistance x comma here or something. Does that make sense? That's the kind of thing we want to be able to write.
Yeah, but the thing I was trying to say before is that the problem with location is that the location interpreter is very special because it always returns a geoposition. So if you get something that has a location, like
I understand. I understand what you're saying.
Yeah.
I understand what you're saying. It takes a certain set of things. Every one of these interpreters takes a certain set of things as input, right? There are other things that's two functions that an interpreter performs. Function number one, accept or reject. Function number two, transform to a canonical form. Am I right?
Yes, but
Yeah,
what I'm saying,
I'm right. So what I'm saying is, what we care about here is the accept or reject function, not the transformation to canonical.
You're right in that it does do both those things, but you're wrong because I'm sure it's implemented. It's going to be doubling the work and doubling the time if it's running on some Wolfram Alpha server. If you do those separately.
Yeah, okay, fine. But I'm just trying to understand conceptually what we're trying to achieve.
Can I just say something about that?
Yes, quickly.
I think that if we want to define this cleanly and not have 15 incompatible type systems,
speech over. What's your point?
We cannot say that location. I mean, if we're gonna call this location, then it's a geoposition. If you call
this
to
the point, what
geo entity, then it can do what you're saying here. But I think that if you define it in terms of interpreter, if you define it in terms of interpreter types, then what you want is that interpreter of that thing returns exactly that thing and not a failure. But if it transforms it, then it's not in the type really.
I'm sorry, I don't understand what you're saying.
I think the argument is that, let me tell me if this is correct, Carlo. So the problem is that you don't like the idea that interpreter of representing location would match the string NYC, because even though it could be transformed to a geoposition, it's a string NYC. It's not itself really truly representing a geoposition.
Yes.
Okay, but I understood that point.
But if you take an entity, that will also get transformed to a geoposition.
Yes,
so
we know. Yes,
clean.
I understand. Okay. Okay. So maybe I said something wrong previously. Let's take this example, right? What can be accepted by the location interpreter, right? So you're saying one of the things that can be accepted is the string NYC, which is something we do not want to match in this case, right?
No, I think, yeah, we don't want to match.
We don't want it to match. That's the point, right?
Maybe. I don't know that we necessarily don't want it to match. I mean, if you have geomarker of quotes NYC, it should probably fail, but I'm not sure.
It shouldn't be full
What
location.
about Battle of Hastings? Do we
right,
want
but this is going to be my main complaint about this, and why I argue this is better served by having lots of specially designed queue functions or something, would be that as we had the discussion with like dates like a little bit ago, a week ago or something, there's going to be cases where it's like interpreter of date of Galileo, and it's like, what do you do there?
Yes, I understand where it's somewhat arbitrary, but let's try to understand the problem we're trying to solve here. The problem we're trying to solve is we're trying to write a function that will accept as an argument any reasonable thing that represents a location. Now the question is, what does it pass to its body when it does that? Does it pass to its body a thing which has been digested and turned into a geoposition, or does it pass to its body? Okay, there are three things it could pass. Okay, thing number one, undigested input, i.e. whatever was said to be able to correspond to a location. Okay, thing number two, let's see, thing number three is fully digested canonicalized, transformed input. I.e., in this particular case, e.g. geoposition.
That sounds extremely inconsistent with pattern matching with everything else.
I know. So
It's the most useful, but the most inconsistent.
Okay, so let's look at what okay. So the intermediate case, I'm sorry? What's the intermediate case? Can we fill that in, please, before you go on to a different topic?
But I think you're not describing the right thing here. When we designed interpreter, there are two steps to interpreter. One step is the interpretation, and that's the thing that turns the string or an entity
I'm well aware
into something. And then there is the restriction function, which is what you're describing here. So, for example,
not what I'm describing here. It's not what I'm describing here.
Let me finish. Restricted is the thing that says, I don't want to accept any integer.
No,
I
it's
want
not what I'm describing here. It's not what I'm describing here.
Yeah, and I'm telling you, you're off the point where we should be talking about. So what's the relationship between interpreter types, restrictions, etc., and pattern matching? It's not, we don't care about the parsing here.
I mean, I feel like restricted, right. I mean, restricted, when you say I have a number and it's restricted to this, or I have a city and it's restricted to being population greater than 1 million, there's an implicit restriction that it be interpretable as a city too, right? So it's
let's zoom out again for a second. What's actually useful? Okay, stop talking about the implementation of interpreter or any of that stuff. I want to talk about what's useful. We're not talking about how it's implemented. We're not talking about how we, connect it to interpreter. We're just talking about what's useful.
Right. The thing that you want, and it's a thing that's not specific at all to interpreter stuff, is the problem of basically checking and canonicalizing inputs to functions. It's extremely common that that you write a function body and you make assumptions that, I'm going to have a geoposition. It's not going to be a geoposition XYZ or a geoposition ENU, and it's going to be all nice and so on. And you want to be able to somehow check that in the arguments and have it be canonicalized in the body.
Right, because the body is going to correctly handle all the different forms. It's merely that you want to pass all those forms through, regardless of whether they are geoposition, ENU or something else, right?
Yes. And the problem is that this is very inconsistent with how pattern matching works right now.
Right, but so let's before we go anywhere else, let's look at that issue, right? That issue. Let's take, in some of these things, let's take something, some of these, it just isn't relevant. It's just a lot of this stuff is, okay. So,
sorry, of these three cases, I think I would choose the intermediate case to avoid repeating work. And
yes,
for example, in this case, it would be entities, but if I pass a country, I don't want it to be converted into a geoposition.
I disagree. I think the intermediate case is clearly hard to follow. Number one makes the most sense to me.
Right, but if it's a do interpreter of location of 30 years war. Right, so what does that even mean? And which of right? Suppose that's 3. What would 2 be in this case? Entity of
in this case, that would be. It will be this.
I feel like this is a different, this is a different problem, right? I mean, this is a problem, but it's like we already have a way where you could say, geomarker of 30 years war, and it will mark this spot. And maybe that's silly, but we do, generally speaking, assign positions to these sorts of things. So if you want a function that has all the same behavior as geomarker and everything like that, then it should handle a 30 years war like
right.
this.
So these are the 3 cases. 1, 2, 3. This is undigested, entified, and interpreted and digested.
And in a lot of cases, 2 and 3 are going to be the same.
But the thing I don't understand about this is like, what is the input to the function in these 3 cases? Does this pattern also transform things or not?
Okay,
That's the question.
We haven't defined it, right?
Right.
Could interpret a pattern accept more than one binding? So kind of like how pattern just takes one symbol as the first argument. Could interpret a pattern optionally take more representing the different states, so you can use them in your function body.
No, I don't think it should. I think
Wait,
that'd be
before you
interesting.
reject that idea, let's think about it for a second. Okay.
Right. So the idea is you'd have one variable that's bound to the undigested and one variable that's bound to the digested.
Yeah, and then you can use both if you wanted to in your function body or replacement rule or whatever.
Or instead of having multiple symbols, we could have like interpreter value, which is like option value.
Yes.
Which pulls it out.
Well, I kind of like the two symbols because it's
yeah,
it's
the
less
syntax
magic.
would be tricky.
And you can use
right?
condition and stuff like that.
Let's take a look at what this would mean. Okay. So let's say we say this. Okay. And let's imagine to begin with that we bind it to a single thing X.
See, I think we wouldn't even
I
want
would
to do that because
this is
that's using pattern. I think the X would actually belong to interpreter pattern in there. We would probably want a nice input form similar to pattern, but that would be the thing that it's binding. And then you can add extra symbols in there to represent the other states.
Right.
Right. So pattern takes a symbol to bind to, and it takes a pattern on the right-hand side. This takes a symbol to bind to and an interpreter type on the right-hand side. And maybe it takes a second pattern to bind to that it will use to bind to the canonicalized value.
Just as a list or okay.
Something like that. Maybe.
Now, and if you do have something on the outside, X : on the outside, then that would just be the original undigested and
bind to the undigested.
Right.
So, okay,
Yes.
so hold on. So then what this corresponds to in our 3 digestion levels, right? If I said, U : that's the undigested thing. Right? That's how I get number 1.
Well, actually, we wouldn't even
Or just
need
X.
multiple bindings because that one there, that is already the undigested one. So we really only need one in interpreter pattern, right? For the
What I don't understand. How do you get both numbers 2 and 3?
By doing what you just did.
Sorry,
with the
no,
U on the outside,
I was
right?
skipping 2 there. So yeah, I was thinking of just 1 and 3 as being the main things here.
Right.
Yeah.
So in this case, what this would do then is on the right-hand side. So this would, I don't know how this would work, but this would be feeding to a thing that is some kind of, interpreter test. Is this interpretable as a location, the thing that's been fed in? So for example, that could be, 4 north, 6 east or something, presumably. That will be a valid thing that would match this thing here. Is that correct?
Yeah.
If I say cases of some list here, comma, interpreter pattern of location, that would work.
Yeah. And then if you wanted the actual interpreted values, that would be the thing that you bind inside interpreter pattern, right?
Right. So then if I wanted this, I would say that : greater than, geodistance, whatever it is.
right with an underscore
Was there an underscore?
On the left.
on the X on the left, right? It has to be a pattern.
Well, no, because
No, actually,
look
it's
at the
not.
full form of
No.
pattern, that
No.
it would just be a symbol like that.
Yeah.
'Cause that would be
Okay.
Well,
equivalent
just
to
like
like
it's the
X :
innards of pattern.
I see. Oh, neat. Okay.
Okay, now one thing is I think this function will be much more useful if it were not specific to interpreter. Like if we had a top level function that was like I don't know what to, for example, geoposition, right? If you apply geoposition to any of the different geoposition like objects, it will canonicalize it to geoposition. So how would you use that as sort of a canonicalized binding or something like that here?
Well, okay, so hold on. Let's imagine it was called pattern category. And it was, mostly it supported interpreter names, but it could have additional ones, and there might be interpreter names it didn't support.
I'm just afraid the interpreter names are going to be a toy because they're going to have to call out to a server.
Well, most of them increasingly won't have to.
Well, certainly if you want the resolve thing, they'll have to, right?
Right. And also, by the way, users can't define interpreters, but in my code I write, I constantly am defining these sort of canonicalizing functions.
I see.
Where the first thing that I do in my function is I say try and canonicalize my arguments. If you fail, the whole thing fails. Otherwise, continue.
Okay,
right?
so that's a pattern where okay. So the pattern that you're defining is test if it is canonicalizable, and then feed through the canonicalized form.
Right. Which is very similar to what we just said with interpreter pattern, except that one is specific to interpreters.
Right.
And the way I see it is it's obvious how you would do this, except for the fact that you need to be able to deal with the case where it doesn't match. That makes sense.
Okay, so then if this said, and how does this relate to the option back? I mean, the question is, could we have a thing that, I mean, this is a bad name, but canonicalizing pattern of, let's say, function here.
Well, I assumed it would be a symbol first, right? It would be X, comma, the function, like with the interpreter case.
Yeah, okay, fine. So let's actually say Y, comma, function, because we could have an X.
Yeah, okay, X would be the outer thing. Yes, will be the uncanonicalized form.
Okay, so canonicalizing pattern of this would be such that it tries to apply this function.
Right. So this is the complication. So okay, in the body, you'll have it'll be true that f of x is equal to y, right? Like that or fun of x will equal y. The problem is, right, exactly, the test that the f of x actually returns something meaningful.
Well, okay, so here's a possibility. So
I mean, it could default to doing the same thing that basic confirm does, of looking for like failures and missing and stuff
Right.
like that.
The default can test can be failure queue.
Yeah.
Well, but there's a different,
yeah.
there's even a simpler thing, canonicalizing pattern. Okay, canonicalizing pattern. And it could be y, comma, fun, comma. Okay, let's say this is just geoposition. And then this says underscore geoposition.
Right. And imagining the geoposition returned a failure object if it failed, which I don't think it does, but yeah.
Well, but it doesn't return a geoposition, I think, if it fails.
Well, I think if it failed, no, I bet it will, but
it will return unevaluated.
I see.
Right.
I see.
I mean, I agree that having it as a pattern there could be useful, but I think it's more useful as a function, both because the operator form of match q is so easy, and the underscore question mark parentheses is so ugly.
Yeah, right. Okay, so fun, but what would be the function here that would test whether it was actually, there would have to be a geoposition q or something?
The operator
Or a match of, sorry?
The operator match queue, like Christopher was saying, would be
Oh,
common.
well, that's not going to do it for you, because as we can see, geoposition.
Well, for geoposition, yeah.
So
Now,
what is the test in the case of geoposition?
There is a GIS backtick geolocation queue that tests all the various geo functions.
Right,
I mean,
but now the question is this
it
test,
could be promoted, but it
which
will
direction? Oh, sorry, go ahead.
No, I was just commenting on the existence of that function and that we could consider promoting it to system
we
at
have
some
a
point.
similar thing with date too.
Mhm.
With we have internal possible date queue because there's lots of things that may be dates. A number can be a date, but it's context dependent how you want to handle certain things.
But now, okay, for this test though, which direction is it? Is it true when it passes, or is it true when it fails? Right, like would you have failure queue there as the default, or not a failure queue?
I think it's true when it passes.
Which is already what we have for the second argument of interpreter.
Okay. But I mean, let's just understand whether assume we could make this function thing work. and possibly omitting that, it would have some default.
Right. So by the way, to do the interpreter pattern, all you would do is instead of writing geoposition, you'd write interpreter of quotes location. Right. And if I remember right, if it doesn't match, it'll be a failure object. It'll fail by default, and it's beautiful.
In this case here.
Yeah,
that would just
and you don't
work.
need the fun. You don't need the fun because the default behavior will be correct.
Right. And then you could probably elide that to just say quotes location.
Maybe. I'm a little nervous about that, but yeah.
Okay, so then this would be, I mean, this is interesting. This would then pass. Well, I think this is interesting. I mean, I don't know if it's. Okay.
It's a little bit, so there's a one minor problem, right? So, right, I mean, in terms of argument checking, we have lots of queue functions, which are kind of the wrong thing for this, right? Like if we had this, we'd want to have lots of canonicalizing functions, like canonicalize this as a number, right?
Yeah, I mean, what do you mean? You canonicalize pi squared over 7 to be a number.
Right. I mean, for example, suppose that I wanted to, maybe numbers the wrong example. But I mean, take
So
right, take like geoposition for an example, right? You'd want to have a function. I think we'd be more likely to have a geoposition Q function than we'd be to have a canonicalize this as a geoposition and take whatever form it is and
That's
conform
because
it.
geoposition is a canonicalizer itself. Right. I mean,
Okay, so I guess then you just put geoposition, comma, and then the theoretical geoposition Q would be the third argument or something. I'm just trying to imagine, because we have a lot of Q functions, right? And we don't have a lot of canonicalizing functions explicitly.
Well, okay, but I think the reason for that is because a lot of things that are ultimately wrappers, like geoposition, do their canonicalization.
Right, but they also do things like throw messages when they fail.
Some of them do. I mean, this is date object probably has a canonicalizing functionality. You know, N has a canonicalizing functionality in some sense. What else does? I bet there's ones with URLs and things like that.
But there are things like, okay, I need to take a valid polygon or something. I mean, in that case, I guess we do actually have canonicalized polygons. One of the only canonicalized functions we have. But if it fails, it's also probably going to fail dramatically as opposed to returning a failure object or something like that.
Put Wolfram alpha with Wolfram result second argument be some sort of default.
What are you saying?
Wolfram alpha with string Wolfram result as second argument. It's very powerful converting anything into a Wolfram language expression. So many of the geo functions, when they don't know what to do, they try this.
There's also semantic interpretation, which I don't know whether they're different or whether they should be different, but
with second argument, Wolfram result.
That's disappointing. Why wouldn't that work?
But this is perhaps too complicated, but 5 miles will convert it into a quantity.
Okay. I mean, this is the kind of thing I would expect, because I think that will work as a, I mean, I'm sure if I do.
Shouldn't be computed location.
Location.
Huh.
For what it's worth, also the semantic interpretation fails on that. So I wonder if it's
That's really weird. I thought those worked. Well, that's a Wolfram alpha parsing thing. Maybe Avery can chase that.
Right.
Yeah, I got it.
So back to the previous section. I think we need a blank colon in front of those things, because otherwise I don't see how you'll ever be able to restrict the pattern in a patterny sort of way.
Sorry, what
So
do
you're trying to say like to specify that it's not a sequence or something.
Right. Or if you wanna right, if you want it to be part of a right. How would you get the X? Right. How would you get the X is what I'm saying.
which X? The Y? Yeah.
No, the X to which that
You'd
it's
put an
applied
X,
to.
X
You'd say
colon
X
before
colon in front of
the
it. Yeah.
canonicalizing pattern.
Wait a minute. So you're saying if I say that, what's wrong with that? I mean, it'll pick up the raw undigested thing. That is whatever the canonicalizing pattern was operating on.
Right. Well, suppose you want maybe you're
If you
saying
only wanted it to
not
match
interesting,
things
but
where the
what
raw
if
bit
you
is a
want to put
string.
restrictions on
Yeah.
X?
Right.
Right.
Is
But
what
As
you
a
might
string.
want, yeah, because you might want to do that just to disambiguate different usages or something.
Yeah, I understand the issue.
So basically we'd have, well, right. So the way that this would normally work with patterns is you'd have an argument to canonicalizing pattern that defaults to blank, but which you could set to underscore integer or something like that.
Right. That's the input. So in other words, it would be instead, and it's a little weird, it would be this. What this is trying to match, what the canonicalized name is, and what the canonicalizer is. That's a little bit.
And then
And then a
the
test
fourth
function.
argument is the test. Yeah.
That's
It might be worth putting the
only
blank.
Only the third one is mandatory.
Yeah, that's a little. maybe we need to change the order if only the third one is mandatory.
Where will we put the blank? I mean,
I think the blank should go third because the most common case. Okay, the minimal case is you just give the canonicalizing function as a test. The next most common case is you want to bind, Y to the canonicalized thing, and then it's only rarely do you need the test or that you need to specify the blank.
fair enough. Okay, but then, okay, we should note here.
Also, taking a step back, all of these things we've been looking at ignore the number 2 from above, because I don't think it'll be common that it even exists. Do we need to have support for that, or can we drop that?
Wait a minute, wait. Fully, what does the Y bind to? Does it bind to the fully digested form?
Well, I don't know what this partially digested form means.
Yeah.
Do you mean that? Yeah, go ahead.
The output of the fun. It binds to the output of fun.
Right. The idea of partial digestion only exists if you have fun and you had some other function that's like the, and I don't know what that would even mean.
Like number 2 seems like an implementation detail for
Fine. Okay.
people would expect to have access to that.
Okay.
As an utterly random note, you probably could do it with nested calls to canonicalizing pattern, where you could put the canonicalizing pattern in the third argument where that blank is. You could put another.
We'll leave that
one.
as an exercise for the reader.
Yes.
Okay.
Or the implementer or something.
Okay. All right. So let's go through this for a second. So what kinds of things do we think would actually be useful? I mean, again, we've got this whole question about what the test does, et cetera, et cetera, et cetera. But, and in the world of restrictions, the second argument of this, if I'm remembering correctly, for interpreter is a restriction. Is that correct, Carlo?
No, it's not correct. Restriction is in the first argument. Because
Okay, it's
high
restricted
qualifying.
of location.
Yeah, the second argument is test, which
Okay,
is different. So the first argument works with the type system. The second argument is a predicate.
Okay, fine. Fine, that's fine. Okay, so let's look at some things that will be useful, right? So, I mean, the thing that isn't obvious to me. Okay, so let's take two cases. One where you really can say f of NYC, and the other where you're saying only things that for, because geoposition of NYC doesn't work, does it? I hope it doesn't. Yeah. Right. So, but then it's f of Battle of Hastings, where it is presumably the case that geoposition of this just works. Right. Giving its canonical form. So I'm drawing a distinction here between, one might want f can accept anything which when wrapped with geoposition. But I think what we're saying here is then the way we write this is f of canonicalizing pattern of x, comma, geoposition.
Right. That gets the second behavior. And if you want to support NYC, then you should say interpreter of location instead.
Yep. Well, this is interesting. I mean, I think. Go ahead.
Well, I was just going to propose one other example because I'm trying to think of sort of built-in existing functions we have that you'd often put in that second argument. So another case where I run into this is things with regions. We have a lot of different like heads and things that represent regions. Like,
yes.
Disk open close is a region, and so is boundary mesh region, and so is whatever.
What would you put there?
Well, I would if it existed, it would be maybe it does actually something like a region queue, which tells you whether it's a disk or a boundary mesh region queue.
No, but remember, this isn't what you're putting there is the canonicalizer, not the test.
Oh, right.
Well, I think that just works. Region of disk works.
I don't really understand what the thing just called region does, but okay, that might be correct.
Region tries to visualize the thing.
Is it a valid region though? Like if you said area of region of disk, is that going to work?
It goes one direction. If region of something gives a picture, it was a valid region. But there are valid regions where region of something does not work because you can encode uncomputable regions properly in our language.
Right, like some crazy implicit region or something. Yeah.
Well, okay, so there are questions about what the canonicalizer names can be here. And we can imagine supporting string second arguments here that are various kinds of things that have been currently subterranean objects. But okay, let me just understand the semantics here. The semantics are, this is a thing which, if that canonicalization doesn't work, and by the way, presumably if there is an error message generated, that message will be visible when you say f of whatever.
Right, like if it printed a message, you mean, yes.
But it's a little weird because the message will be printed, but then the match will fail.
That's true for pattern test as well, though. I don't think that's a major.
Okay, fair point.
Right, but this is right. I mean, this is why I was, I think it's useful to think about what functions that we have support this, right? Because I think, right, you could imagine that we could go out and implement a whole bunch of functions, just like we have a bunch of queue functions and we have boundary mesh region queue. We could have a function that sort of purpose is to try and make something into a boundary mesh region, because and maybe that function is, because right now the way we do that normally is we just have it so boundary mesh region tries to do that, but then if it fails, it usually fails catastrophically. And also in that particular case, I think boundary mesh region of disk doesn't work. I think you're supposed to say boundary mesh of disk or something like that. So we're not very consistent about this sort of canonicalizer. We think of it more as like a constructor than a canonicalizer.
Right. So this might force some thinking about that. But I'm also, okay, like here's another example. Let's say that I want a function where, well, maybe this just works, where okay, I want a function where it's units, but the units represent money. Right, where I want that to be, I can have euros, I can have pounds, I can have whatever, but I can't have meters here. Making sense?
Well, you could always write you could do a unit convert. I don't know what unit convert does when you give it meters and tell it to turn it into euros.
Complains.
Well, you're
You
saying
could do-
How gracefully does it complain?
We have the currency interpreter, right?
sure we do, right? But that's
Yeah.
an interpreter going from a string. So if we say unit convert of hash, comma, US dollars,
Right. The question is though, if it doesn't match, is it going to print messages or something?
right.
And the answer is yes. It prints a message and then returns dollar failed.
Sander is commenting here on a live stream. Let's see, would it query the interpreter a bunch of times if you had 10,000 city names? The answer is yes, and the whole point is we're trying to make that much faster. And we've had this long-running project to have a local version of that interpreter, which I keep on hearing it's almost ready. And hopefully by the next version it really will be ready. But maybe Avery, you could check into that. That's a Jeremy Michelson production.
Okay.
Well, okay, this clearly requires more thought. But by the way, there was another thing that Sander had sent through to us about, I think it was about min of a round or something like this, which I think got lost in some crazy interchange.
It's on the LCC agenda for today.
Okay, fine. Okay, then good. We have our act together. Good stuff. Well, this is interesting. This is not something that had been on my radar to think about this in a serious way. I feel like this is not settled here, but at least we've got a beginning. And maybe we could do a little bit more thinking about this and bring this back. Does that sound reasonable?
Yeah. Sanders' question does bring up if there's special handling of lists, because interpreter has special handling of lists. That's
well, I mean, the question of how.
Not true. Interpreter doesn't even special handling of lists.
it threads over lists. It threads over lists.
I mean, you can, if you, instead of calling interpreter on a list, you call it on alternatives, it also does one single API call. It batches things whenever you don't map it.
Right, but it's not.
Sorry, but
it's interpreting it's interpreting the elements of the list. It's not interpreting the list, right?
Yeah. But
yeah, that's my point. That's my point.
It's pseudo listable, but what I'm saying is that if you do something super complicated with compound element and repeating element, it will also collect everything into one single list.
But my point is it interprets the elements of the list. So I wonder if this thing should do the same thing and if the test function should work on elements of the list or on the list as a whole, right? That's an open question.
Right, there's two questions. There's the question of efficiency. Is it going to consolidate calls? And there's the question of the thing we wrote earlier of canonicalized pattern, comma, interpreter of quotes location. That will accept a list right now.
Right. So there are many detailed questions here. My feeling is this canonicalizing pattern concept that really basically it's going to end up with a bunch of string second arguments that are another family of kind of categories of thing, much like we have an interpreter, rather than, and maybe there is a escape clause of you give an explicit function, but my guess is that the useful stuff is going to be a whole collection of specific, categories of thing.
I disagree, because the question is, if we were going to introduce a string argument there, like quotes boundary mesh region or something like that, why would we not just make it a symbol and make it an actual function that you can use in other purposes?
Yeah, well, fair point. But then then what we're talking about is a boatload of new functions,
right?
Which possibly we should have. But I mean,
right, and then that's why there's the question of how it interacts with the existing constructors and with queue functions, and what the convention for such functions would be if we wanted to have them.
Right. Well, I think let us can this get explored outside of this meeting and come back and let's get a list of what some interesting, plausible canonicalizer functions might be.
Yeah, we can do an inventory and
Right. I mean, I don't think it's going to be huge. I mean, let's say there are 5 of them, then it's a perfectly reasonable thing for us to expect to just introduce those functions. If it's 25, then it's a more complicated story.
I mean, we have like hundreds of queue functions.
Yes. And here, I mean, we've got lots of types of entities, but I'm not sure that we need, there should be a generic version of this for any type of entity that then subspecifies the type of entity, I would think.
Sure.
Let's just take a look at roughly what. My gosh. Okay, so we got, go ahead.
this is a combination of looking at our old design notebook of things to migrate from alpha and some of the things we've learned from Wolfram Alpha Notebook Edition. This was, Michael provided a list basically of things that don't exist in Wolfram language or aren't in the version of Wolfram language that alpha runs on that are most frequently used in Wayne.
Right. Well, I think we've got several different categories here. We've got things that are essentially math, area between curves, implicit D, which we now have, but it probably isn't. I mean, we have that in version 13, right, Michael?
Yep.
Right,
But it's just that that's not the thing that the cloud version is running on
right.
for Wayne, unfortunately. Okay, so we should break that. I mean, like truth table, that's Boolean table, isn't it? But maybe it's a beautified version of Boolean.
It's a beautified version.
Right. So how many of these, can we break these down into what is a beautifier? What's a, mathematical function, like this is a beautifier. Right. I mean, that would be like factor integer form of a list would be some beautifier there.
Yeah.
Let's break that down into beautifiers versus actual functionality, like diagonalized matrix sounds like functionality.
Is it?
It's kind of some version of Jordan decomposition.
But is it something for which we could have a function that does it? Or
No, I think this one is probably more specialized to the audience.
I mean, I don't know what this returns, but right, I mean, this is either some version of eigensystem or Jordan decomposition.
Correct.
And I think it's the latter.
okay. I mean, some of these like area between curves. I mean, at the level of language, why isn't there just one integral minus the other? Or am I confused?
Well, if it's smart and it does, it actually figures out, does the absolute value and figures out which is higher, then, it isn't.
Mm-hmm. Well, it probably is smart that way.
And figures out intersections.
In a symbolic way.
Yeah.
So fine. So that's a possible function that is I don't know what it would be called or what, whatever, but that's a possible, I mean, we could imagine, area between curves, which right now is a function repository function, right?
Yeah. All of these are WFRs.
Yeah. Which makes, which is possibly where they should be.
Yeah, yes and no. Like the inactive factor integer is not suited because it isn't really a function that does something. It's more like a star form. So we don't have a good functionality to just display something and then use it as the same thing. Like it's still the integer.
I see. But wait a minute, it's in an active form. So I mean, we do have a way to display inactivated forms.
Yes, but then if you use it, you would have to activate it. It doesn't auto-activate. Like 12. Show me the factorization. Now square it. You don't want the exponent squared, you want 12 squared.
Well, okay, but you're asking for something that we don't have a real mechanism in the language to do. I mean, it's either
Matrix form is not so different.
yeah, but that only works. Matrix form only works on an output line.
No, I think this has been fixed. It works now better.
No, the behavior hasn't changed. The
I mean, if I say
documentation has been improved, but the behavior hasn't changed.
if I say this, I'm still going to be cooked if I say this.
Yep.
Right, that isn't what you think it is.
No, I meant kind of like the matrix itself, then matrix form, and then percent squared.
Oh, sure. This works because it has / matrix form there, and therefore it burrows. It is that / matrix form is representing the fact that it's going to burrow.
But the same could be done for the factorization.
Absolutely, which is why the first thing I said was what you want is a factor integer form.
That's what I'm saying the whole time. So no
Okay,
disagreement
fine.
any
yeah,
form.
We're both saying the same thing.
For
Right,
which
right.
there's already a ticket somewhere. It just, requires effort.
Right. So that's, I mean, okay. So each of these has some story like that. So it's going to take us a while to go through these.
Although I don't know that I agree that each of them, I mean, like,
But they may not all make it. Okay, but each one has a story about what it should be doing. Wow, what's iterated log? What does iterated log mean?
You take log until you get complex. It's like some naive version of inverse Ackermann.
What the hell do people use that for?
For very large complexity classes.
Well, it's a lovely function, but I mean, so let me understand it. So you go until it is the last logging before the thing goes negative.
Yeah.
But don't you need to know how many loggings you've done?
No, it tells you how many you did.
Is there a WFR function for it?
Don't remember.
I didn't see one.
But so what is its return value?
An integer.
I see. So it is telling you how many times it has to log it. Oh, I see. So it's the inverse of 2 to the 2 to the 2 to the, it's inverse tetration in some sense.
There is a WFR.
Oh yeah, you're right.
Yeah, that's what I've said, yeah.
Sounds like a worthwhile function to have. Yeah, I mean, I think this seems like a fine function. Is that the iterated log is a really weird name for that. Is that what it's always called?
That's the literature name, yeah.
I mean, I'm confused because in no sense is it the iterated log, it is the cardinality of logs. You get what I'm saying?
Yeah.
That's a nice function. And the default is E, the base of the iterated logs. Is that right?
Yes.
Well, it seems like a fine function. But anyway, we should probably this. And what does logit do?
What should do?
Another fine seeming function. I mean, this is used. How is this used I mean, this is used in a bunch of statistics things, isn't it?
I think so.
Anybody know here? I mean, both of these functions seem like things that we should build in. I don't see any reason not to. Anybody?
I mean, no objection on my part.
I mean, if it's just something that evaluates away, then I don't see any value in it.
Well, except for the fact you're writing code and you want to show what's going on in the code, and that has very high value.
Yes, but it has no value as sort of a built-in function. I mean, you could.
Well, yes, it does.
You
because
could right. You could write your own right. I mean, this is
yes, but you're not going to. That's the whole thing. We've
not
learned
even a
over the last-
one-line function. This is.
I'm well aware. That's one of the things we've learned over the last God knows how many years. That's what I used to think. Exactly what you just said.
No.
40 years ago, I
Let
would
me
have said that.
no, Stephen. But then people complained, well, it doesn't get this special value right, and you can't do and you can't do this series right because it evaluates away. Right?
Well, the evaluating away thing, yes, there are complaints about that in certain cases. However, the value of having something which, like, it's a logit function and you just want to put that function in, it's really worthwhile to just have that function, not to go look up the definition. And so I mean, it just doesn't make sense. Okay, anyway, this is probably going to be a longer discussion. Let's just see what roughly we have here. I don't know what all that's going to be. Why is digit get?
This is especially people ask for ridiculous, like the Google's number of 3/5 or something like this, where you have no chance to do it. It's especially this nth fractional digit that.
Don't we have nth digit at this point? I thought we had nth digit. Didn't we not put that in?
I think we renamed it, but I don't remember what the new name was.
We published a resource function for it from the math team on Wolfram Alpha, but I don't think it's.
I think there's a
No, we
built-in.
definitely had long discussions and.
It's a bit frustrating that none of us know its name.
I think it's number digit.
All right.
Yep.
Okay. And what's the difference between that and digit get? Anybody?
We discussed whether the number represented the count from the first digit or the count from the first position with respect to
Wait. We've got a definite function here. My question is, what's the difference between that and the proposed digit get?
I mean, I don't think there is one. I think
Okay, so then it's just a mistake. I mean, that's interesting. I think we should consider these.
So I'm just trying this number digit, but it doesn't really work for large numbers, which is what people put into alpha.
Okay, fine. That's a different issue. That's not a reason to have a new function.
Yeah.
That's a reason to get it to work properly.
Yes.
And what should it do in those? I see. In the case where it's a rational, for example, then it knows what to do.
Exactly.
Okay, so that's just an implementation thing for number digit.
Yeah.
And if you've already got a way to do that, let's feed that into Nick or whoever else is dealing with number digit. That seems like an easy thing to take care of. All right, I think we've got other things then to cover another time. I personally, I kind of believe in the sign degree thing. I think we've added some functions like that, and they have been a good idea. Anybody want to comment on that immediately?
Yeah, I think the main concern was just like how far we go with it, and do we have a degree version of all the trig functions?
Right, so that's not one function, that's 12 functions.
Yeah.
Yep.
And
Yep.
I,
All right.
We have a rotate degree.
Oh,
I hope not.
yeah, I hope not as well. Well, that's an argument.
Rotation transform degree or whatever.
Yeah, that's crazy.
Angle vector degree.
All right. Okay. Right.
Maybe
Well-
I'll do a more thorough inventory and just kind of try and come up with classes, and we can look at it in a little more detail. But
I would argue it is a good thing that every single function that expects an angle expects radians.
Yeah.
And, if you want something else, just as in geo range and in geo functions, everything expects meters if you give it an integer. And if you want something other than meters, you use a quantity.
There's a reasonable argument for this. All right, we should wrap up here. And some of you are involved also in the design review that's coming up in a couple of hours. All right, thanks a lot. See you later.
thanks,
Right.
everyone.